Okay, so the main takeaway, what I want you to know is how to be able to find the domain and range of exponential functions, which is something that we have already been working on. And then a new word that we're going to learn is the asymptote. The P is silent, so the asymptote. Know what it is and know how it affects the line. It will affect specifically the Y value. So know what it is, know how it affects my graph. Okay, know what it does. Now, the asymptote, this is actually something that won't be on your assignment, but that is something that we want to go ahead and make sure you understand just in case it's on the STAR test. First things first, though, I'm still noticing that a lot of us don't know the parts of the equation, the parts of the function. You guys aren't understanding the differences and how to name those parts. So we're going to label this equation right here, or this formula. Anything that's on the other side of the equal sign, that is what we consider the equation. You get the variable A and B from the equation. You get the variable A and B and X from the equation. Now, the variable A has a couple of different names. The one of the names is an initial value. Initial, and I'm just going to put V period. Initial value. If you see the words initial value, beginning, starting point, anything like that, that is because you are grabbing this same exact number from a word problem. Okay. But if you're looking at a graph, you can grab the same exact number. My bad. I said that backwards. If it's a y-intercept, that is what's coming from a graph. But all three of these are the same exact number graph. I can find the number 3 in an equation. I can find the number 3 in a word problem. Say we started off with 3 students. That's a word problem. Or I could find the point, the coordinate 0, 3 on the graph, but all 3 of those are still representing the same number. Okay. Now, where we always get confused or where we always have trouble is the factor. B is your factor. So if you ever see me write B is greater than 1 or B is less than 1, that's because I'm describing the factor. The factor always starts at the number 1. The factor always starts at the number 1, but it depends on what you do to the rate that will give you that factor. Now, up until now, I've just been putting the R and the F on the bottom. I'm just filling this in just so you know. I just put the little R in the bottom, F on the bottom, but I'm going to fill it in for the purposes of the notes. The factor is the number that you actually, bless you, grab from the parentheses. The factor is the actual number you grab from the parentheses. It is the number that you are multiplying to get from one Y value to the next. We start off with 2 people. Remember that great grandparents example? You started off with 2 great grandparents. You multiplied those by 2 to get 4. You take that 4 and multiply it by 2 again. So you're multiplying by 2 every single time. If you look at this equation, we're multiplying by 3 every single time to get to the next value. So the factor is also known as your multiplier. Multiplier. Your factor is known as your multiplier. What number are you multiplying to get to the next value? And that factor can be split into 2 categories. If I add the rate, that gives me growth. If I subtract the rate, that gives me decay. And R, just for those that still don't know, R is your rate, and your rate has to be in the form of a percent. Your rate has to be written in the form of a percent. So for example, in a word problem, unless you physically see a percent sign, that is not the rate. It would be the factor. If you physically see the percent sign, that is a rate. So you have to use the rate to find the factor. If there's no percent sign, that's just the factor. You don't have to do any of this. Got it? Questions on that? All right. Now, when you are finding the domain and range of an equation, or no, of a graph, when you're finding the domain and range of a graph, few different things that you want to label. Few different things you want to label. First of all, we're going to label the X and the Y axis on every single graph. X and Y, X and Y. Okay. And one point that you always want to identify or that you always want to label is your y-intercept. So what is the ordered pair, or what is the point for the y-intercept here? 0, 1. And go ahead and label every single point that you ever label. Go ahead and put an X and a Y over it, because I'm still having a lot of people putting a Y and an X instead of XY. XY, not YX. Okay. We're going to answer several questions over this graph, but specifically for domain and range purposes, remember when we had a parabola, you had two endpoints, but they were either both a maximum and you had a minimum, or if it was upside down, you had two minimum points and a maximum point. You don't have to draw this. Look at this graph. Look at this graph. You only have a minimum and a maximum. You only have a low and a high. There's no middle point that you need to include into the domain and range. Okay. So what I want you to do every single time is label endpoints or arrows. Label the endpoints or the arrows every single time. Label the endpoints or the arrows. Start with the y-intercept, then go straight to the ends of both of the line on both sides and label those points. Label the endpoints or the arrows. I'm going to start right here because I think some people are still copying this part down. So if I go to this endpoint on the left, I see an arrow. I'm going to actually draw an arrow coming down to it, because I'm going to write something else right here. So I don't want it to interfere. Okay. And I have an arrow over here. So we're also going to label this one. I'm going to start with this one just for, you'll see why. X, Y. All right. So right here, with this arrow on the right, your X values, this arrow is going to continue going to the right because it's going up. It's going to go to the right very, very slightly. You're not going to notice it very much, but it's going to continue. So this is, and you have your positive X values on this side. So this would be considered positive infinity. Now, because that line is also going up, and it doesn't stop, that's also positive Y values, so positive infinity. Let's go over here to this side. If I'm going to the left, notice how your X values are negative and they become more negative. If I keep going, I'm going to eventually reach negative infinity. So right now, does anybody have a question over the positive and negative infinities? If you think back to first learning the 4 quadrants, you have your negative X values, but positive Y values here. You have positive X values and positive Y values. So you could also associate that. Down here, which you won't need it, but down here we have positive X values and negative Y values. And in this third quadrant, negative X values, negative Y values. So negative, negative. See that? Now the Y value is what's different. This is where your the word asymptote comes in. Everybody notice that dotted line? Okay. So you tell me, where do you think, I actually graphed this on my Desmos, so we're going to go here. Tell me, where do you think this line is going to cross? It's actually a 3. Where do you think this line is going to cross the x-axis? Where's my x-intercept? Where's my 0? What's up? At 1, 0, 1, but 0, 1's right. That's a y-intercept. That's not an x-intercept, a y-intercept. I mean, an x, that's a y-intercept, not an x-intercept. I'm asking for the x-intercept. -1 is right here between 0 and 2. -3, you can actually tell that it's not touching, but Yesenia is saying -4. So that's a good place to start. Notice how the line is right on that -4. So right now we're assuming that it's crossing at the -4 and that my 0 is -4. But let me zoom in. Does it? No. So let's keep going a little bit further down. Where does it cross? Okay, we see that it's actually finally touching at -6, right? Let me zoom in. Does it touch? No, it's never gonna touch it. And that is all thanks to that dotted line. That dotted line that I've already graphed for you will not always be there. It's an imaginary line that is called an asymptote. This dotted line right here is called an asymptote, okay? An asymptote is an imaginary line that acts as a boundary to another line or a curve. You can have asymptotes with linear equations or with linear functions, and you could have asymptotes with quadratic x. It acts as a boundary to another line or curve. Think about, if those of you that play sports, think about like soccer. You can get as close as you want to the boundaries, to the outside lines, but if you cross over, then there's a throw-in, right? So you have a limit. There is a line that you cannot cross, and that is what that asymptote is acting as. It's a limit. It doesn't allow you to cross it. And in this case, it does not allow you to cross the x-axis. It does not allow you to cross the x-axis. And that is always going to, the asymptote and the answer for the x-intercept will always be the same in algebra 1. That asymptote, we don't actually mess with the asymptote. It's always going to stay in the same spot. Once you get to algebra 2, that's where you'll see what happens if you change the asymptote. You see that? But this is not a value that we actually mess with in algebra 1. So your answer is always going to be the same. And you're actually not going to get questioned over it on the homework. But I do want you to understand, I want you to know what it is. It is an imaginary line. Now that line is what type of line? What type of line is that? It's a horizontal line. And there's specific ways to notate a horizontal line. Horizontal. There are specific ways to notate a horizontal line. We learned how to use those in semester 1 with our straight lines. We used HOI, where the A stands for horizontal, the O for zero slope. The Y is what we really need out of this, stands for Y equals a number equation. The only way to notate, or the only way to describe a horizontal line, is by using an equation. That equation is always Y equals. Your asymptote will always be Y equals a number. And that is because it's a horizontal line. The only way to describe a line is by using an equation. Think back to quadratics. The axis of symmetry was a line. That one was a vertical line, so we used x equals. This one, we use Y equals. Now let's figure out what number, because the answer to this will be the same in every single one of these problems. If it's going towards the x-axis, let's put some points here on my x-axis on the other side. What is the ordered pair for this point right here? 1, 0. Where my Y value is 0. What about this one right here? 2, 0. Where my Y value is 0. Here? 3, 0. where the y value is 0. So any point on the x-axis, what is your y value? 0. So that means that this line, even though it doesn't actually touch the x-axis where the y value is 0, it's going to continue to approach it. It's going to continue to get close to it. So the equation of this horizontal line is y equals 0. The equation of that horizontal line is y equals 0. The line is going to get close to it, but not actually touch it. And the only reason you're going to use these zeros and the asymptote is when you're only going to use it with the range, and you're only going to use it in places where you see an arrow that's going towards the dotted line. Okay. And I'll point out those every time I see it. That way you guys know what to recognize. So my asymptote is y equals 0. 0 is another word for an x-intercept, and we just went over it. Even though we thought it crossed or it touched at the -4 and the -6, it didn't actually touch it. It was very, very close to it, but it didn't touch. So if it doesn't touch, there's no intercept. So with exponential functions, there will never be an x-intercept. It will never cross the x-axis. Okay. But now that we have all of the other points labeled that we need, we can go ahead and answer the rest of these questions. What is the initial value?
1.
1. And when I'm asking for the initial value, I'm asking specifically for which one? Y value, the initial y value. Okay. Now, if you look at that graph, is the line going up or down from left to right? Up. So that means we're looking at exponential growth because the line is going upwards. Okay. And now for domain and range. Now for the main part of the lesson. Always, always label your minimum and maximum, or always write minimum and maximum under your domain and range blanks. A lot of us don't write these in, and that's where we see a lot of mistakes. So only looking at the x values for the domain, which one is my minimum, my lowest number, low number? Which one is my lowest number? Negative infinity, 0, or infinity? Negative infinity. Anytime you have an infinity, go ahead and underline that. What is my maximum? My highest x value? Negative infinity, 0, or positive infinity? Correct, positive infinity. And anytime we have infinities on both sides of the inequality, how do we write that, or how do we notate it? How do we describe it? All real numbers. All real numbers. And I want you to go ahead and circle that, because I've noticed that because we haven't actually been circling all of our answers, some of us are still flipping things that shouldn't be flipped. All right, now let's look at the range. Let's look at the range. I have positive infinity, I have 1, and I don't have anything here. Even though you see an arrow, anytime you see the arrow touching or getting close to that asymptote, to the y equals 0, that means it is approaching 0, but never actually touches it. So you are going to use the number 0 as your lowest or your minimum value, okay? This will only happen with the range, and it only happens where you have an arrow going towards the dotted line. Got it? All right, so my lowest y value is the number 0, and the highest is what? Positive infinity. Positive infinity, you underline. We're actually going to write another note coming off of this 0, so don't worry, because I saw some confused looks. Now, what part of this answer do I actually keep? No. The 0. 0 has to go to the front, y has to go to the back. So we end up with y is greater than 0, but not equal to, not equal to. Don't underline it. And we're going to write that in. We're going to write in why you do not underline. So draw yourself a little arrow coming off of that 0. The reason we don't underline this is because it approaches, I'm going to draw a little star, approaches It approaches, those of you, okay, what does approach mean? It gets close to, but doesn't touch. But doesn't touch. If it doesn't touch, is that an intercept? No. So that means it's not equal. If it doesn't touch, it's not equal. You don't underline it. It approaches but doesn't touch the x-axis. Oh man, I meant to write the x-axis. It approaches but it doesn't touch the x-axis. And on the x-axis, what did we just learn? That's where your y value is 0, where y value is 0. It approaches but doesn't touch, meaning it's not equal. That's why we don't underline it. It approaches but doesn't touch the x-axis. We're using the number 0 because every point on the x-axis is 0. Okay. You could also see that. We could also see that with the Desmos. Give me a second. Everybody got this? All right, so let's look at it on the Desmos real quick, and then after this, everything will be pretty quick. Right here. So everybody pay attention to these values right here. Look at just the y value, because we're talking about range, correct? We have 0.03, 0.02, 0.01, 0.006, 0.003, 0.001. If we zoom in, 0.0003, 0.0002. So even though you have a bunch of zeros, it never actually is 0, 0, 0. You see that? That's why we say it gets close to the 0, but doesn't actually cross or touch the 0. Okay? Any questions so far? No. Do I need to explain asymptote? Anything like that? No. All right. So number 2. After this, it's all going downhill. It'll be pretty quick. So here we go. Strap in. So, all right. Couple of things you always want to label. First of all, you always want to label your x and your y axis. Make sure you're not mixing up your x and your y values. The next thing you want to label is your y-intercept. What is that y-intercept? 0, 1. Put an x and a y over it in that order, always alphabetical. This dotted line is considered my what? Your asymptote. Remember, the p is silent, and the equation, or the only way to describe that asymptote, is with an equation. What equation is it? Y equals 0 every time. It's never going to change. It's always going to be y equals 0 in algebra 1. Very specific in algebra 1. I don't want y'all to run off and tell your algebra 2 teacher, Ms. Ramirez said it's 0. No, it's going to change. And then what else do we need to label?
Arrows.
The arrows, the ends of it. They're not always going to be arrows, but in this one, again, we do see arrows. Okay. So I need my X and Y. All right, over here in this quadrant, in the second quadrant, my X values are negative. So this is negative infinity. My Y values are going up. If we go up, they're positive, positive infinity. Questions? Okay. Everybody have that point? I need to scroll down because I know you're the middle of the book is like right there. So I'm going to put the point down here. X, Y. All right. My X values this way are going, they're becoming more positive. We're going to higher numbers. So that would be positive infinity. But notice this is the area, or this is the point where my arrow is reaching what? The dotted line. My arrow is reaching or trying to go toward my asymptote. So the Y value is going to be 0. And we're going to write this one more time. We're not going to write it again. So that's, but we are going to write it in approaches, but doesn't touch x-axis, but doesn't touch x-axis. It approaches, but it doesn't touch the x-axis. So we're getting close to the number 0, but we don't actually touch it. So not equal to, okay? And now we're ready to answer all the rest of the questions. What is my initial y value? 1. Or is the line going up or down? Down, so we see decay. 0 is another word for x-intercept. It's another word for an x-intercept. Do we have an intercept? No, never do. Not in algebra 1. Asymptote, an asymptote is an imaginary line. The only way to describe a line is with an equation, y equals 0. In algebra 1, always y equals 0, doesn't matter. Now the domain and range, the main part, minimum, maximum. Minimum, maximum. Everybody have those growth, 0, and asymptote? So I can raise it up for the rest of the people? All right. All right, only look at your x values because we're doing domain. Is my low number negative infinity, 0, or positive infinity? Negative infinity. Underline because it's infinity. What's my maximum? Negative infinity, 0, or positive infinity? Positive infinity. 2 infinities means it's what? All real numbers. When you have all real, once you have your final answer, circle it. Ooh. Circle that final answer. Because I have a lot of people only circling the wrong thing. All right, what's your lowest y value? Positive infinity, 1, or 0? 0. Because we have that 0, are we going to underline it? No. What's my maximum? Positive infinity or 1? Positive infinity. At the infinity, yes, you do underline. We don't actually keep it, but what do we have to do with that 0? Flip it. And if you flip that, don't forget, you also have to flip that symbol, y greater than 0. Y is greater than 0. Questions? After that first example, it's all downhill. Ready? Next example. All right, somebody give me what do I need to label? There are several things. Your x and y. Let's start there. There's my y value, or maybe my y-axis, x-axis. What else? The y-intercept. What is the y-intercept? 0, 2. 0, 2. Make sure you put an x and y over it. What else? The asymptote. The asymptote is a horizontal line, so I can describe it with the equation. Y equals what? 0. Make sure you put a y equals 0 right there next to that dotted line. That's my asymptote. That's like a force field that doesn't let the line cross over. And what else do I need to label? The points. Now, these points they've already given us the numbers for them, but you still have to put an x and y over it. You still have to put an x and a y over it. And just because you see a point doesn't mean that that's the end. You need to double check to make sure if it keeps going into an arrow, okay? All right. Ready? That's all that needs to be labeled. Let's get started with the good stuff. Initial y value. What's my y value? 2. Are we growing or decaying? All right. 0 means x-intercept. What is my x-intercept? None. There isn't one. It doesn't touch because of the asymptote. And what's the equation of the asymptote? Y equals 0. I just put the line over it so y'all don't think it's an O. Yeah. Y equals 0. So now label your minimum and maximum, and we'll get to that. Minimum, maximum, minimum, maximum. If you want to write low number, high number, that's up to you. I'm not going to do it every time. All right, domain. Only looking at the x values that we've labeled. Only looking at the x values. Which one's my smallest? -4, 0, or 3. And at where you see the -4, do you have an open or closed? So we leave it alone. The only other 2 numbers left, 0 and 3. Which one's the highest? 3. And where you see the number 3, there's a closed circle. There's a closed circle. Now, because I have numbers on both sides, the whole thing is my answer. This is where I'm seeing a lot of people mess up because they just want to keep that -4 and flip it. No, we have a number, we have a number. We keep everything, okay? Range, only looking at the y values. What's my smallest y value? 10.125, 2, or 0.5? So 0.593, and I picked up the wrong thing. 0.593. At the 0.593, is it open or closed? Closed. And what's my highest number, 2 or 10.12? All right, so 10.125. And at where you see the number 10.125, is there an open or closed circle? Open, so we leave that alone. But the whole thing is my answer because I have numbers on both sides. Questions so far? You think I'm going too fast, or if I need to explain something, let me know. All right, example 4. What do we need to label? Your X and Y axis, X and Y axis. Okay, what else do we need to label? Your Y intercept. I'm gonna go ahead and put my Y intercept down here. What is the Y intercept? 0, 3, 0, 3. Put an X and a Y over it. Okay, what else do we need to label? Okay, we're gonna put the X and the Y over that one. We have another endpoint. That endpoint is not labeled, so we actually have to find the numbers. Now, the reason I didn't give you the numbers for this one is because you can actually see it. Should be easy to see. What's the X value? 4. The X value is 4. Go straight down and then you go to the 4. If you go straight back to the left, it falls in between 16 and 14. So what number would that be? 15. 15. There's one more thing I'm not labeling. The dotted line. The dotted line is called my, and what is the equation of that asymptote? Y equals 0. What does the asymptote do? It stops the line from crossing the x-axis. Good. It stops the line from crossing the x-axis. All right. So initial y value is what? 3. Are we growing or decaying? 0 is another word for an x-intercept. What is it? None. It doesn't cross the x-axis. It doesn't touch the x-axis. Asymptote is a line. The only way to describe a line is with an equation. What is that equation? Y equals 0. Now label your min and your max. Everybody ready? All right, domain, only looking at the X values. Which one's my smallest? -7, 0, or 4? -7. At the -7, or where you see that number, is there an open or closed circle? Closed. Once again, the only other 2 X values left, 0 and 4. Which one's the highest? 4. Where you see the number 4, is there an open or closed circle? Open. So we leave that alone. But because we have numbers on both sides, the whole thing is my answer. Range. What's my smallest Y value? 0.176, 3, or 15? 0.176, 0.176. Where you see that 0.176, is there an open or closed circle? Underline it. And what is the highest number, 3 or 15? 15. And at that, where you see the 15, is there an open or closed circle? Open, so leave that alone. Don't underline it. Questions? All right, number 5. First thing I want you to do is I want you to go ahead and correct this equation. This 2 should be a 5. That 2 should be a 5. That 5 is in what spot? Initial value. So you'll see why it's wrong. All right. All right. What do we need to label? X and Y. Start there. X and Y. What else? The asymptote, and it's what? Y equals 0. The reason it's Y equals is because it's a line. What else? X and Y on the Y intercept. You have to grab something? It already gives us a point for the beginning. So just put an X and a Y. And yeah, we have to find the coordinate for the, yeah, sorry. Yeah. So label your X and your Y. It's an arrow. Now, in the first quadrant, we labeled it with the very first example. In the first quadrant, we have positive X values. So this is positive infinity. In this quadrant, or in this also in the first quadrant, your Y values are going up. So those are positive Y values, positive infinity. You only use a zero where the arrow is going toward the asymptote. You only use a zero where the arrow is going toward the asymptote. Got it? All right, let's answer the questions. Initial Y value is 5. Growth or decay? 0 is another word for an x-intercept, and that is none because it doesn't cross. Why doesn't it cross? Because of the asymptote. The asymptote is an imaginary line, meaning it's not always going to be there for you, but that is what's responsible for that line not being able to cross over. The equation will always be y = 0. Once again, only because of algebra 1. Algebra 2, different thing. And I got to repeat it because there's always one person that got to tell their algebra 2 teacher, just remember septus. Okay. Domain, only look at your X values. -1, 0, or infinity. -1. And at that -1, is there an open or closed circle? What's left? 0 and infinity. Positive infinity. And any infinity is closed. Now, what part of the answer do we actually keep? The -1 and the X, but make sure you flip it. So it's X is greater than or equal to -1. Circle that answer or box it in, whatever. That's the final answer right there. Y values. What's your smallest Y values? 1, 5, or infinity? 1. And we also see a closed circle there. All right, what's the highest? 5 or infinity? Infinity. But we are going to flip this. Just because we write that number on the left side doesn't mean it has to be a negative number. That's okay. It is a positive number at that point. So we get y is greater than or equal to 1. Box it in, circle it, do what you got to do. Example 6. Angel, head up. All right, label your X and your Y axis. I'm just gonna put a Y there. X axis. Your asymptote, that dotted line, y = 0. What is your y-intercept? 0, 3. Put an X and Y over it. What is the endpoint on the left? -1, 4. X and Y. Now, what do we notice about this arrow? It's going down, but it's also getting close to what? To my asymptote. So that's going to affect which value, my X or my Y? It's going to affect the Y value. If it's getting closer to that dotted line, it affects the Y value. Now, my X values are positive, so that's still positive infinity, but that Y value is the one that's going to be 0. Okay? My Y value is 0 because the arrow is getting close to the dotted line. All right, what's my initial Y value? 3. Growth or decay? X-intercept? None, because of the asymptote. The asymptote is a line. What is the equation of that line? Y = 0. Am I giving everybody enough time to copy those? Okay. I don't know if I was going too fast there. All right, domain, only look at the X values, -1, 0, or infinity. -1, there is a closed circle, underline it. What's the highest, 0 or infinity? Infinity. Now, because we do have an infinity, we got to flip this other side. So X is greater than or equal to -1. Box it in, circle it, do what you got to do. Y values, only look at the Y's, 4, 3, or 0. 0. Do I underline that 0? Why not?
Because
It doesn't cross, it doesn't even touch the x-axis. So it does, when you underline, understand that when you underline the inequality, you're saying that we're including 0. You're saying that it actually touches 0 and it doesn't, okay? All right, the highest number, 3 or 4? 4, and that is a closed circle, but I have a number and a number. So this one, you box in the whole thing. The whole thing is my answer. Number, whole thing is the answer. Example 7, finishing up. Real world scenario, real world scenario. I know y'all get tired of hearing it, but coronavirus. I got this graph straight off of the website. What does the y-axis, what did he say? That's fine, I don't care. What is the what do the values on the y-axis represent? Thousands of what? The cases, the number of cases. So I'm going to write that down, number cases. When you have a real world example, it's very important that you pay attention to the titles. If they're not there, make them. The x-axis, what is that describing? Days in March 2020 to be specific, to be exact, okay? March 2020, I didn't print these out today. So we have a beginning and we have an end. We have a beginning and an end. We get these numbers off of the word problem. Look at the bottom paragraph. It says, if on March 1st, there is my day, X, Y. If on March 1st, that's my day, how many cases? 16 confirmed cases. So 16 cases. And on March what? 26, there were how many? 73,000. That's going to be the other ordered pair. Ready? So March 26th is the day. 73,000. I'm going to put 73K for those of you that have never seen that. K means 1,000. 73,000 cases. And put your X and Y. Y values, cases. X values, days. Y values, cases. X values, days. Got it? All right. We're only going to write the domain and range for this. Ready? We don't have to answer any other question. Domain is your X values. X values describe the days. So only look at the days. We started on what day? On the 1st, and we ended on what day? 26. This is a real world example, so they're both going to be underlined. Okay. Range. Range is my Y values. My Y values represents my cases. So only look at the cases. What is my lowest number of cases? 16. What is the highest? 73,000. If you want to do the 000, that's fine. If you want to do 73K, okay. All right, so glue this into page